name is Matt Weedleton. I am the crush plant manager at Purdue's Cofield, North Carolina location, which was built in 1982. Our plant can crush 40,000 bushels of soybeans in a single day, which produces roughly 1,100 tons of products. At Cofield's crush plant, we produce soybean meal, soy hulls, and both crude and degummed soybean oil. At this facility, we have a grain elevator, a feed mill, and a crush plant. And as you might imagine, they all work together. The grain elevator, which can store 1.5 million bushels of beans and 1.5 million bushels of corn, supplies the crush plant with soybeans and the feed mill with corn. The crush plant also supplies the feed mill with soy meal, one of those products we produce through the crush process. Because we have all this on site, we keep an average of 70 trucks off the road weekly by conveying soybean meal straight from the crush plant to our feed mill. Once the feed mill has all that corn and soybean meal, they turn it into feed that supplies approximately 300 chicken farms per week. We partner with Wellens Energy Solutions for steam. They burn local green wood chips every year to boil water and produce high-pressure steam. This steam passes through the turbine to spin the generator. Then Wellens sells power back to Dominion Energy of North Carolina and extracts the exhaust steam from the turbine generator, and they supply us with that exhaust steam. This steam, which powers our crush plant and feed mill, is the cheapest per 1,000 pounds produced across all of our facilities. So let's get back to the crush plant. Let me tell you a bit about the process the soybean goes through once it enters our crush plant. First, the elevator conveys the beans directly to the crush plant by way of our garner scale, where the beans are weighed and then sent to our day tank for a short stay before going into the plant. Next, the beans are run through our cracking rolls, which do multiple things. The top set of rolls crack the beans into halves and break the hulls so that it can be separated from the bean. The bottom set of rolls cracks the beans again. This helps us get to our goal, which is every bean split into 4 quarters. After the cracking rolls, we have to separate the hulls from the soybean, or what we like to call the meat of the bean. This is done with aspiration, which lifts the lighter hulls away from the heavier cracks. This step is essential in providing the customer with high-quality, low-fiber meal. After that aspiration process, the hulls are sent over to our gravity tables. There, we can catch any of the smaller soybean pieces that were light enough to be aspirated off. The meat of the beans captured in this step are put back into the process to continue their journey. The hulls are then sent to our hull grinders and then sent to storage, where they will be loaded onto trucks into our load-out facility. At this point, we have mostly clean soybean pieces that will head to the last step before oil extraction begins. In this step, the beans are heated to 162 degrees by our bean conditioner and then run through one of our 5 flaking mills. They use hydraulic pressure to squeeze the bean into a flake. These flakes will be squeezed to 15 thousandths of an inch thick, which is roughly the thickness of a business card. This is another very important step in the process. Getting the correct thickness on the white flakes allows you to get more oil out of the flake during extraction. Now we've made it to extraction. During this part of the process, we use a chemical called hexane to remove oil from the soybean flakes. Inside our French deep bed extractor, we wash the flakes a total of 7 times to get as much oil out as we can. When the extractor is done with its cycle, now we have 2 products, white flakes, which go to our desolventizing toaster, and miscela, which goes to distillation. Miscela is a mixture of soybean oil and hexane that needs to be separated. This happens when the miscela goes through our triple distillation system, which is designed to strip the hexane out of the soybean oil. When the oil leaves the final oil stripper, it is now considered crude soybean oil, which goes to one of our 2 1.4 million pound storage tanks. From here, the oil can either be loaded onto a truck or rail car for transport, or sent to our degumming process. Let's circle back to those white flakes we ended up with after the extractor. Now they head to our desolventizing toaster, or DT for short. In this vessel, the flakes travel down through 8 different decks, each one removing more hexane out of the white flakes that we capture and reuse in the extractor again. Once the product comes out of the DT, it is now considered meal. When the meal leaves the DT, it is still around 18 to 22% moisture. And we need to get that moisture down to 12.5% before it goes to storage. This process is achieved in our dryer cooler, or DC. This vessel has 3 decks in it that remove the moisture and bring it down to our desired level. From here, the meal goes through a set of grinders, so there are no clumps in it, and there it goes to our meal storage. From meal storage, we can load product into trucks or send it straight to the feed mill. The last step in our process is oil degumming. To complete this, we run the crude oil through a centrifuge and remove most of the heavy metals and meal fines that are caught in the oil. This step helps make the oil cleaner and more stable for storage. I hope you have enjoyed our journey through the soybean crush process.